Hello everyone, my name is Daryl. I work as a software developer. In this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient, it'll just be the one that I come up with first as I'm working through the problem. So this looks like we're going to be doing another tree-related program, and this one is number 108 on the LeetCode site. This is another easy one: convert sorted array to binary search tree. So give it an array nums where the elements are sorted in ascending order. Convert it to a height-balanced binary search tree. A height-balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. So basically it's balanced. So they're going to give you, once again, this int array, and we're going to be using that tree node class again. And they just want all the values in this tree, and it needs to be as balanced as possible. Okay. And so they're showing these two are basically what would be accepted. So example here, if you're given 1 and 3, in this case it's going to have to be one different. And you can either have it like this or like this. Okay, so the nums.length is going to be between 1 and 10,000. And each value is going to be between negative 10,000 and 10,000. Nums is sorted in strictly increasing order, which is obviously important to this. All right, so I'm going to copy this over and I will start working on this. So first we're going to need this tree node class. Just copy this here. And then I'll copy in this function. All right. The way I'm thinking about doing this is if you look at the int array that you're given and you take the length and divide it by 2 and then do a floor on that, it should always give you the index that you can use as your middle node. So in the case of this, it would be 5 divided by 2, which is 2.5, and then do a floor, and that would give you 2. And incidentally, because, of course, arrays start with index 0, you would end up getting 0, 1, 2. You'd end up getting this 0 as the middle node. And since these ones can go either way, this would be 2 divided by 2, which is 1, which you'd get this one as the first one, but that's a perfectly acceptable answer as that being the middle node. If it's even, basically you can either choose the left one or the right one. It doesn't really matter. And then what I'm thinking afterwards, so like in the case of this one where you have 0, then we can go from that index down to 0, and all we need to do is to keep adding. Like, I don't think it matters. In these examples, they don't have really long ones, but I think all that matters is that they have the same height, or it only differs by 1 in the case where it needs to be. So all we should need to do is I could like keep making the left node as I march through here, right? So we're at 0, we go to the left and we make the left node -3, and then we go to that node and make its left node the next value, and you kind of keep doing that. And then I could do it, like, I don't think the left or right really matters, but I could make it so the right side just keeps marching down the right way. And I guess I'll need to just try this out because they don't say that a possible answer would be, for this one, would be 0, -3, 10 here, -10 here, and then having 0. Oh, they have 0, 9, 5, which is interesting. Well, it's interesting to me that it's here you have -10, -3, 0. Are they saying that if you read it with in order traversal, then it would work? Because in this case, you would say -10, -3, 0, and then it would go down to this left node 5, 9. But with this one, in order traversal, yeah, that would still work because it would go left and then it would go to this one, which is -10, then -3, then 0, then 5, then 9. So I think it doesn't say here, but it looks like the tree needs to be set up so that in order traversal would work. In that case, my algorithm would need to be slightly different. So we find the middle, and we can make the left side be straightforward like that, where it just keeps making it the left node, because that would always work. But then when we go to the right side, all we would basically need to do is a slight variation where the next node down here would actually be the last node, would be the biggest node. And then, So like you just start from the right side and then move towards 0. You just keep doing that because then it would, yeah. Okay. So I think that's how we're going to try to do this. So first let's create a middle index, which is going to be equal to nums.size divided by 2. And we're going to do a, I want to make sure that it does a proper division and not an integer division. Just so that I can make sure this works. And for floor, we'll need to make sure to, yeah, this thing has that, so that's fine. So first I'll make base node is going to be equal to tree node, where the val, or we can just pass the val, it's going to be nums of middle index. Got 2 int, there you go. So that's the middle node. Then let's create a work index, and it's going to be equal to middle index. And while work index is greater than or equal to 0, it's going to be our first loop here. And we can go ahead and do -1 on this, because if base node ended up being 0, then this would be -1 and this loop just wouldn't run, and that would be fine. And we're going to need current node equals base node. So you're just going to say current node dot left is equal to, well, we're going to create a new tree node here. So new node is going to be equal to a tree node with a value of nums of work index. Then we just say current node dot left is equal to new node. Current node is equal to new node. And work index minus. So that should work. Then we can just do the other side. So remember, we're going to need to do this slightly differently. So work index is going to be equal to middle index plus 1. And then while work index is less than or equal to nums.size minus 1. But actually, remember, so in this case, we're not going to do it from the middle. We're going to do it from the... So we're going to set it to nums.size minus 1. And then we're going to keep going as long as it is bigger than... As long as it is strictly bigger than the middle index. Although the first one we want to do differently than this loop, actually. So let's just do it like this. So if work index is greater than middle index, we're just going to do this one slightly differently. So, or we could do it in the loop, but let's just do it here. Maybe we will just do it in the loop. That would make more sense. So just check in here specifically if the work index is equal to nums.size minus 1. So if it's the first one, and we'll actually want this to be the case, or the else case, because in the if statements you always want it to be the common case first. So if it's not equal to that, let's see. Either way, we want a new node, which is going to be equal to tree node with nums of work index. Then, if it's not the first time that we're making this first node, then current node dot left is equal to new node, and we want to make sure here to change current node to middle, not middle index, it is base node. So if we're not creating this first one, then we want the current node dot left to be that new node. Else current node dot right is equal to new node. After that, we just do current node is equal to new node, work index minus. And then we should be able to, at the end here, return base node. And I want to go ahead and try this with the example they have here. Or actually, why don't we just try it real quick? Let's copy this into here. And I believe we will need to add this import. Let's try running that code. Awesome, accepted. Let's go ahead and submit that. Okay, we got a wrong answer. So the input was 0, 1, 2, 3, 4, 5. And it's kind of hard to read what the actual output is. So they expected... So the middle one here, it's one of those ones where they're going to be slightly different. It would end up being this one. Well, this would be... Let me think about this. This would be 6 divided by 2 is 3. So it would end up being this one, the 3. So I figured out what the problem is. And this, once again, comes back to, and I've had this problem before with some of these other LeetCode challenges. They don't provide an example which actually explains the problem. So based off of the examples that they gave me and the description that they gave me, my program is working properly. But they didn't show a good example here that illustrates the problem that I'm having, that they're expecting something different. So based off of these examples, my stuff's working right, but I understand. So basically, if I look at the submission, so as we went through the way that I coded this, the way it works is my result for this 0, 1, 2, 3, 4, 5 is that I have a 3, and then it goes down to the left and it has 2, 1, and 0, just going straight down to the left. And then from the 3 in the middle, I go to the right and I have a 5, and then I go to the left node and I have a 4. But they don't like that. So what they expect is, once again, in order traversal, which they don't explain in the description. But they're expecting a 3, and then the next row is a 1 and 5. And then from the 1, you have the 0 off the left and the 2 off the right. While going down from the 3 to that 5, we just have a 4 to the left, which would read as this in order traversal. And technically, they would all have the same depth. But once again, they didn't really explain it properly. So I just have to change my algorithm over here. So I'm actually going to have to wipe out most of my code here, because this is going to have to work quite a bit differently. And we're going to end up making a function here. We're going to end up needing to make a function that is create child nodes. Okay. So this is going to be another recursive answer, just like our previous ones. So now, so basically that whole kind of initial logic that I was doing where I find the middle index here, well, you're still going to need to do that initially, but where I find the middle index and then I figure out what needs to be on the left and the right side, we're going to need to do that through every single level, basically, to make this work the way they're expecting it. So we are going to possibly return, but we'll see. I'll leave that as nullable for now. But you'll just need to set, go back to the description real quick. We need to make sure we handle the special case where the length of nums is 1 or 2. Because if it's 1, it wouldn't want to run any of these. So we'll just do if nums.size is equal to 1, return base node. If nums.size is equal to 2, then we can just do something very basic where we just say val new node is equal to tree node of nums middle index plus 1 and base node dot right is equal to new node return base node. All right, so we might end up putting these, well, let's see, we'll just leave those there for now. But then if that's not the case, then you're going to want to say base node dot left is going to be equal to create child nodes, and we're going to pass in nums dot slice 0 to middle index dot to array list. Are you able to do that? Pass in, let's see what this returns. Returns a list. That's fine. And consequently, we do base node.write equal to create child nodes nums.slice from middle index to nums.size -1. Or there's probably a better way to do that until nums.size. Actually, though, we want to do middle index +1, and here we want to do middle index -1. Return base node. And we're actually going to need another current node is a tree node. And we'll pass that in as base node here. Base node. So basically our base case for this is going to be a recursively called function. Our base case is going to be similar to these if it's either 1 or 2. So it's going to be similar. So if nums.size is equal to 1, then in this case, we're going to say val new node is going to be equal to tree node with nums0 as the value. And actually, we're just going to be returning this. If nums.size is equal to 2, it's another base case. This, though, we'll need to make new node. That's going to be a tree node with nums1, because that's going to be the second value. Val new left node is equal to tree node with nums0. Then we say new node dot left is equal to new left node, and we return new node. So we're just setting that up so that we probably want to capitalize this N. That's correct. So if there's 1, then we just return a new tree node with the value that we have. If it's 2, then we make a setup where we have the new node is going to be the higher value, and then we're going to create a left here with the lower value. So it's going to go like this and then this. Otherwise, we want to do basically what we did up here. Current node, we'll need to make a new node value here, and it's going to be, well, we'll need to find the middle index. And new node, same thing as here. It's going to be equal to that. And new node dot left is going to be equal to create child node. It's actually going to be pretty much the same as this, just that instead of passing base node, we pass new node. Same thing here. And then we return new node. And this can be private, that's fine. Let's try this solution real quick. Run code. Okay, so that one was accepted. Let's submit. Okay, we got an array index out of bounds exception. When we have, that's the input. So that's the case where the length is 2, so it's doing this. So let's see, new node is equal to tree node of, well, the middle index, if it's 2, it should be 2 divided by 2 is 1, which actually would be the, okay, I see what's wrong here. Yeah, there is no, you need to not do this. And Okay. Yeah, you need to not do that. And let's actually do that. Let's say left and 0, because we know the size is 2. I think that corrects the issue. So let's run the little example there. That works, and then we submit. All right, there we go. So apparently this isn't a particularly good example, especially when it comes to memory usage or computation. Maybe there's a way to do this without doing recursion, because recursion is typically a little slower than some other methods. But recursion was an easy way to code this up. But this does kind of go back to the issue that I have with some of the problems on this website. We've run into this a few times if you watch a lot of my LeetCode videos, where the examples don't properly explain the exact way that they're expecting the answer to be. And in-order traversal isn't even listed here as how you're supposed to set this up. You're just supposed to figure it, which that I was able to figure out by looking at the examples. So that's technically kind of fine. But they should have had a bigger example. Then I wouldn't have wasted my time coming up with that first solution that was wrong and then having to basically redo it to use recursion. But anyways, it is what it is. All right, so let's go over the code real quick. So first, we're getting in that nums, that's an int array, and we're returning the tree node. So we're setting the middle index equal to the nums.size, so this is the size of the array. So if it's 3, we're going to divide that by 2. That would get 1.5. We're going to floor that to get 1, which automatically handles the index offset that you normally need to do, because this would return a 1 if the size was 3, which is going to be the second index. So that's fine. Because in this case, we can use, if the amount of values is even, they allow us to use either the left or the right. In our case, if the size was 4, we would divide that by 2, and we'd have an index of 2, which is the third index, which is fine because you can use that 1. Or you could have used 1, but this formula works fine for what we're doing here. So let me just create a base node, and we're going to set that base node to have the value of the middle index, because this is going to be the middle of the tree. And we just have some of our quick little results that we don't need to do this recursion if the size is either 1 or 2. So if it's 1, we're just going to return that base node. If it's 2, we're basically just setting this up so that the left node has the smaller value, because if we have a size of 2, our base node is going to be 1, which is going to be the second value in that array. So that's why we're using 0 here, setting it to the left. So in order traversal, we'll put that in order. Then we're going to start our recursion. So base node.left is going to be equal to create child nodes, which actually returns a tree node, which is going to be the child node of this one. And we're going to do nums.slice. So we're going to take from this int array, we're taking from index 0 all the way up until and not including the middle index. And we're passing the base node because we need to know, or actually this is a very good point. We never actually I could actually remove that. So I was initially thinking that in here I was going to do the attaching in here to the node that gets passed in, but I didn't end up doing that. So that shouldn't really change the results of maybe it'll change the memory a little bit. Let's actually do that real quick. If we remove that, I just want to see if that is a lot better. I know I'm explaining the code, but I just really quickly want to see if that's a lot better. Oh, apparently that was actually a worse answer, which is really weird. Wonder why that would be a worse answer. Let me just submit that again. Because why would passing a value that... Why would passing a value that we don't use give a better result? I don't know. Oh, I guess these percentages end up being a little bit different every time. Anyways, let's go back to this. So for the explanation here, I'm going to remove that though because we don't use that. So we're just basically passing in the left side of the array and then the right side of the array up until the size. And then in this, so this is the recursive function as denoted by these recursive calls here. So if the size is equal to 1, we're just going to return a tree node with that value in it. If the num size is 2, we're going to do basically similar to what we did up here. We just create a new node, create a new left node, which is in the new node we put the bigger value. In this new left node we put the smaller value, and then we attach this smaller value to the left of the node that we're going to end up returning. So it's like one node here, and then the left node is the smaller node. And we return that new node. Otherwise, we need to do recursion. So we're going to get the middle index again of this new nums that we have here, which is a list instead of an int array, because that's what slice returns. Then we're going to set our new node equal to a new tree node with the middle value in it. And then we're recursively going to call this again, calling the left side, calling the right side, and of course that'll keep recursively calling until it hits one of these two base cases, and then it will go back through the recursion tree and give us the answer. All right, so I hope that helped you guys out. Thanks for watching. Catch you guys next time.